Hey guys, my name is Dan Tintel, and I'll be doing WebWork 9 related rates problem 2. So in this equation we have, in a simple electric circuit, Ohm's law states that V equals IR, where V is the volts, I is the current, and R is resistance in ohms. Assume that as the battery wears out, the voltages decrease at 0.03 volts per second, and as the resistors heat up, the resistance is increasing at 0.02 ohms per second. When the resistance is 400 ohms and the current is 0.01 amps, at which rate is the current changing? So I know a lot of people don't like long wordy problems. I know I definitely don't. So the best way that helps me out is just highlight what you know first that pops out to you. So the first thing that I'm going to write out and see is that it decreases at 0.03 volts per second. And I know that it's not V, but that's going to be the derivative of volts over dt. So write that on the right side of the paper. dV over dt equals negative 0.03 volts per second. It is negative because this voltage just decreases right here. We also know what dr over dt will be, and that will be the 0.02 ohms per second right here. And that will be positive this time because it says increases. And this is the ohm symbol too, if you guys don't know that. Now we can go to the real question too. So I'm going to write down even the when part. When the resistance is 400 ohms, so when it's 400 ohms, and it is also 0.01 amps, so 0.01 amps, and we're trying to find where the current rate is changing. So not I, but di over dt. So derivative in amps over the derivative in time. So now with the given equation, we can write this down. V equals I times R right here. Now we can use that and take the derivative of it. So now it'll be dV over dt equals, using the product rule, we can use the derivative of I, which will be di over dt times keeping the R, the resistance. Now we can add that to now keeping I amps this time, times the derivative of R, dr over dt. So now this is the easy part. Once we have the equation set, we can use the stuff that we have, that we've written down in the first step, to plug in the equation we have built right here. And instead, this is a good way to write down also what you have, you know what you know first, so you're not looking back in this big wordy area to see what you have when you have it written down right here. So now if we plug in dV over dt, we know that's negative 0.03 equals, we're trying to find di over dt, question mark. So we can write that down, di over dt times the resistance, 400 ohms, plus I, which is 0.01, so 0.01, times dr over dt, which is 0.02. So now we're just trying to solve this. We're going to use algebra to help determine that. So the first thing I would do is obviously multiply these two. So 0.01 times 0.02, and I got 2e to the negative fourth. E, if you guys don't know, is just 10 to the whatever power is right next to it. So right here would be 2 times 10 to the negative fourth power. So I can write that down, negative 0.03 equals, I'm going to flip flop these two because I like to have the numbers out first and then the variable. So 400 times di over dt plus 2e to the negative fourth. Make that 2 better for you guys. So now what I'm going to do is subtract the 2e negative 4 to this side to the negative 0.03. So minus 2e negative fourth. These will cancel out. Negative 2e to negative fourth over here. So negative 0.03 minus 2 to, now you're going to hit the second button. Then the comma, e, that's how you get the e, negative 4. And that will get you can see my calculator, negative 0.0302. So negative 0.0302 equals 400 times di over dt. Now, using algebra, again, we can use do divide by 400 for both sides of the equation. So 400 will cancel out, 400 here. So now you can just do divided by 400. Now you get negative 7.55 e to the negative fifth equals di over dt. And this right here will be your answer. And depending on how the question is asked, you also might, if you don't like the e, it's not 10 to the negative 5 power. So you can also write it, if you want to do a decimal form, it'll just be negative 0.0000755. And also you can do this by just moving the decimal place 1, 2, 3, 4, 5, and just double checking your, the decimal place. So we right here is a negative 7.55 times 10 to negative 5 is at which rate the current is changing. I hope this video helped you out to study for exam 2, and good luck on that one. Have a good one.